Okay, this is example 11, and I'm going to read through the directions. I did part A for you guys at the very end of class, but I'll go ahead and finish it. That way you can get a good idea of how to do it, and then I'll get you started on example 13. That way you can go back and do 12 and 14. So it says y equals the square root of x, y equals 0, x equals 4, and the directions say find the volume of the solid generating by revolving the region bounded by the graphs of the equations. So we have the graphs of these equations about the indicated lines. So there's a part A, B, C, and D for each one of these. Okay? So, and same thing for number 12, and same thing for 13. 13 and 14 just have an A and B. So I'm going to zoom in a little bit, and I'll do all of example 11, and then I'll come back and do example 12. So here we go. Slide that over. Example 11. So what I'm going to do first, I'm going to sketch the area of the region. So I have the square root of x. And we have, so we have y equals the square root of x, we have y equals 0, and we have x equals 4. 1, 2, 3, 4. Okay? So the region is bounded by these three curves. So the square root of x is the shooting star, y equals 0 is the x-axis, and x equals 4 is the vertical line. So we're looking at this region right here, the shooting star, the vertical line, and the x-axis is the boundaries for this region. So this is the area of the region that we're going to revolve. Okay, so there it is. Shaded in there pretty good. That'd be completely shaded in, obviously. All right, so part A, we want to rotate it around the line y equals 2. Now, we know this point, it would probably help to know what these points are as we start rotating this. So we're going to rotate it around the line y equals 2, but let me go ahead and label all these points here. This is the point 4, 0. And you can get that just by plugging 4 into this, or we know that's 4, 0. But over here, this line on the shooting star, we know that's the point 4, comma 2. That's pretty easy to get if you just plug 4 into the square root function right here. Square root of 4 is 2. So I'm going to rotate it first along the line y equals 2. So this is part A. So 2 is, let's see, this is up 1, up 2. So there would be the line that we're going to rotate it around, y equals 2. So this is my axis of rotation. So I'm revolving it around this. Okay? So we're going around the horizontal axis of rotation. Now look at it. Since we're revolving it around this, this is my shaded region right here in black, or this red part, I guess, since I switched colors. I'm taking this red part and I'm going to rotate it around this horizontal line at 2. So notice there's this white stuff here that there's a gap. Remember, your area has to be completely flush with the axis of rotation for it to be a disk. So part A is going to be a washer. So I'm going to do the volume is pi times the definite integral from A to B of the outer radius squared minus the inner radius squared. So we need to find those two radii. Okay? So we have volume is equal to pi times the definite integral. We know it's going to be from 0 to 4 because everything's in terms of x. So we're going to go from 0 to 4. Now we need to find those radii. So outer radius, I'm going to use a different color here. So we measure our radius from the axis of rotation. So right here is the axis of rotation. So I'm going to measure from that. And the way I'm going to do this, I'm going to measure the distance. So the outer radius would be axis of rotation to the furthest boundary of that shaded region. So that's going to be from here to here. There's a vertical strip. So from there to there. And that distance from that graph to from the top to the bottom is just subtracting those two functions. So we've got the horizontal line at 2 and we've got the horizontal line at 0. We're just going to subtract those two. And it's obvious that over the whole thing here, you can see the radius is always going to be 2. So we're going to take basically the whole cylinder. So outer radius there would be r of x is going to be 2 minus 0, which is just going to be 2. Now we'll go to the inner radius. So we're going to take the whole cylinder. See, if I do this, I'm going to get this whole cylinder, if you will, this whole thing. Okay? And then what I'm going to do is I'm going to subtract out this cylinder. Okay, I'm going to carve that out. So I need the inner radius. So the the inner radius is just going to be this right here. And that'll be that top minus bottom again. So that's y equals 2, so inner radius would be 2 minus the function, which is this, square root of x. So there's my inner radius. That's that distance between those two. And so we're taking the whole cylinder and we're carving out this part right here as we rotate it around so that we just end up with whatever this is in the red and black. So outer radius squared is going to be 2 squared minus the inner radius squared, which is 2 minus root x squared dx. So then my setup, its volume is equal to pi times the definite integral from 0 to 4 of 4 minus the quantity 2 minus root x, quantity squared. And if you were doing this by hand, you would want to multiply this out right here, simplify, then integrate, and to get your answer. But you can use your calculator to get the answer for that one. Okay, that's part A. Part B, same thing. Clear this. Part B, now we're going to take the graph, same graph, square root of x. Okay, square root of x, and we've got x equal 0 and x equals 4. 1, 2, 3, 4. So same graph again. So we're going to take this shaded region once again, but now we're going to rotate it around the y-axis. So we're going around this. Okay? And remember, this is the point 0, 0. This is the point 4, 0. And this is the point 4, 2. And it's pretty important to know those points because that'll help you find your x and y values if you have to do your boundaries. So I want to go around the y-axis this time. So my axis of rotation, again, it's another washer because if I'm revolving around this, notice you got this white stuff here. You're going to end up rotating from here to here, and you've got this stuff right here in white you're going to have to cut out. So my outer radius is going to be from the axis of rotation to the furthest function away, which will be the vertical line at 4, and then my inner radius is going to be here. So I've got my outer radius, there's big R of x, and then I've got my inner radius, little r of x. Okay, now that inner radius could have been anywhere. That inner radius could have been here, it could have been here, and that's why it doesn't matter because we're using a function. So big R of x, for part B this time, we're doing part B, is going to be the vertical line. We're going to go right minus left, so it'd be 4 minus 0. This is 4, the vertical line at 4, and this is 0. So 4 minus 0, that's the outer radius, which ends up being 4. The inner radius ends up being, okay, right minus left. So we're going to do the square root of x minus 0. But since I'm doing this in terms of y, I screwed up there. This should be in terms of y. This should be r of y. This should be little r of y. And that's the same thing up here. I should fix that. This should be little r of y, and that should be big R. This one right here should be big R of y. Okay? This is in terms of y. And the reason it's in terms of y is because we're rotating around the y-axis. And so little r of y is going to be the function to the right, which is the square root of x. But since it's y equals the square root of x, we need it in terms of y. So we're actually going to have to solve for x. So we're going to square both sides, so it's y squared equals x. So it's going to be the function to the right, which is y squared, that's this thing right here, minus 0, which is y squared. So volume, here we go, it's a washer. It's going to be along the y-axis now. We're not along the x-axis anymore, so it's going to be from 0 all the way up to 2. That's 0 up to 2. See the y value. From 0 to 2. Okay, all the way from 0 to 2. So it's going to be along the y-axis, 0 to 2. Then it's the outer radius, which is 4 squared, minus the inner radius, which is y squared dy, and that's your setup. So if you want to set, oh, I forgot my pi out front. Don't forget your pi, 0 to 2. So it'd be 16, that's squared. 16 minus y to the 4th dy. Okay, don't forget. Outer radius squared minus inner radius squared. So we're subtracting out that white part as we rotate it around. Okay. Part C. Let's do that one. Rotate another one on that one. Vertical axis of symmetry, or a vertical axis of rotation. Get it right, Jeff. So we got the square root of x. 1, 2, 3, 4. Go back and sketch the region again. Here's the area we're trying to sketch, or we're trying to rotate. we're going to rotate it around the vertical line, x equals 4. So this time, this is also your axis of rotation. The boundary is your axis of rotation, which means now it's going to be a disk, which is nice. Okay, so we're going to have a disk. So we're going to have volume. I'm going to write the equation this time so I don't forget things. Pi times the definite integral from c to d of r of y squared, because it's we're rotating it around a vertical axis symmetry. So everything has to be in terms of y. So our limits of integration, c to d instead of a to b. We want to be in terms of y. This is in terms of y, and this is in terms of y. So volume, pi, definite integral. It's going to be from along the y-axis, this all the way up again. This right here is the point 4, 2. So that'll help you see that we're going up to 2. So from 0 to 2. And then the radius squared. Well, you measure from the axis of rotation. So I'm going to use a different color here. Here's my axis of rotation. Measure to the function. Just figure out what that distance is. So it's going to be right minus left. So r of y is going to be 4 minus. We have to have this solved for x again. So it's x equals y squared. Remember? Did that in part B. So it's going to be 4 minus y squared. Okay? So that is our radius, 4 minus y squared. So it's going to be 4 minus y squared dy. And if you want to, we can solve this one. This is one you can do pretty easily by hand. You have volume, it's going to be pi, definite integral from 0 to 2. If you multiply that out, it's going to be 16 minus 8y squared plus y to the 4th dy, and then you do your FTC, and then and plug it in. But we'll just use the calculator. So figure that out with the calculator. That would be the setup, though. Right here is where you get your points on the AP exam. Part D, one more. Okay, again, we'll sketch the region again. Same region, square root of x. There it is. 1, 2, 3, 4. The reason I keep sketching, I'm using these same graphs again. So same boundaries. Okay. Now we're going to go x equals 6 is the axis of rotation. So we're rotating around this vertical line. So now it's a washer again, because we're going to have this in here that's going to have to be subtracted out. Okay. So everything needs to be in terms of y again. So we're going to have r of y, your outer radius and your inner radius. So for this one it's a washer again. So volume equals pi times the definite integral from c to d of the outer radius squared minus the inner radius squared dy. It's the same thing every time. So it's going to be pi, c to d again. So it's going to be from here to here. So it's from 0 to 2 again. And if you're along the x-axis on this one, it's going to be 0 to 4. If you're along the y-axis, it's 0 to 2. It just depends on which one you're going along. All right, outer radius. Measure from the axis of rotation. So there's your outer radius. You start from the axis of rotation and go to the function furthest away, the furthest distance. Inner radius will be this one. So there's big R of y. There's little r of y. So we're going to have 6. The outer radius is going to be 6, this thing right here, 6 minus this, which is x equals y squared again. So 6 minus y squared. Inner radius is just going to be 6 minus, this right here is 4. So 6 minus 4, which is 2. So we got our outer radius. So we're going to have 6 minus y squared minus 2 squared dy. And there's your setup. And you can simplify it if you want, but we're just going to plug it in the calculator and get the answer. So there you have it. Okay? I'm going to do also problem 13 for you, just so we can get a different graph. 13, we'll sketch the graph. We have the parabola, y equals x squared. Okay, so I'm going to draw that one first. That one in red, there's y equals x squared. And sometimes it's a good idea to label these if they're not drawn. On the AP exam, if they're drawn, they'll be labeled. Y equals 4 minus x squared. Now I need to think about that one. 4 minus x squared. I know it's a parabola opening down. So here's what I'm going to do. I'm going to see where it crosses the x-axis. I'm just going to real quick check and see where it crosses the x-axis. So I'm going to set it equal to 0. Factor out an x. We're going to get 4 minus x. So it crosses the x-axis at 0 and at 4. So 0, and then 1, 2, down, so I bet it does something like this. It doesn't have to be perfect. I mean, you can graph it on the graphing calculator, all I care, but this is one that you probably would want to know how to do by hand. I imagine this could be a non-calculator one. So the area of the region, the only enclosed off region with these two graphs is the boundary. They didn't give us anything else as boundaries would be right here. So it looks like we're going to get a lot of washer stuff going on because it's not going, there's no way this is going to completely touch everything we rotated around. So part A, rotate around the x-axis. So we're going to rotate around this. So this is going to be our axis of rotation. So definitely a washer because you have white space from here to whatever this x value is, and I don't know what that x value is. We can find that. So definitely a washer. And since we're talking about it, let's go ahead and we know this is 0. Let's figure out what this is, this point of intersection. To find that point of intersection, all we have to do is set those two equations equal to each other. All right, add the x squared over, we'll get 2x squared. Subtract the 4x so we can set it equal to 0. Okay, 0 it out. Factor out of 2x, we'll be left with x minus 2. So we get x equals 0 and x equals 2. And see, that's why you can't trust what you did by paper. So it looks like I didn't graph this perfectly. It looks like this is actually 2. So it's the point, so from 0 to 2. Okay? So we'll keep that in mind as we go through these problems. All right. We know it's a washer, so it's pi times the definite integral from A to B of the outer radius squared. I want to talk about something now that some of you probably are realizing is when we do top minus bottom and right minus left, it actually, you don't even have to do that. Let me explain why right now. So we're going to have pi times the definite integral from 0 to 2. When you do your outer radius, remember you're going from the x-axis. So the outer radius, I'll do it in, let's see, we'll do it in blue this time. Outer radius would be to that function right there. From the axis of rotation to the function furthest away. Now, outer radius, I'm always going top minus bottom. And the reason I'm doing that is because that's the way we do area between two curves. So the top one is the 4x minus the x squared. The bottom one is the x squared function. And so your outer radius actually simplifies down to 4x minus 2x squared. There's my outer radius. Now, you technically could go bottom minus top. And the reason you can do that is because when I plug the outer radius in, I'm squaring it. So no matter what I do, if I go top minus bottom or bottom minus top, it's always going to be positive after you square it. This number is always going to end up being positive. But I always teach top minus bottom. And the reason I do that is because that's the way we do area between two curves. And if I'm teaching top minus bottom, it kind of just reinforces that always. So I'm going to always do top minus bottom. All right, inner radius would be from here, axis of rotation, to the inside function. So there's little r of x. So that's going to be the outside, this function, which is x squared. Okay. Oh, I didn't do the outer radius correctly. I'm sorry. I did not do that. That's frustrating. Frustrating. Outer radius. Some of you are probably wondering what the heck I was doing. Outer radius. Outer radius is from the axis of rotation to the outside function. So it'd just be 4x minus x squared minus 0. I apologize. So we're just going to have 4x minus x squared would be your outer radius. So sorry about that. 4x minus x squared is your outer radius. Minus the inner radius, because we're subtracting out that white part. Inner radius is going to be the x squared function, so x squared minus 0, which is just x squared. So minus x squared. Squared, inner radius squared, the x. Don't forget to square them. And there's your setup for that. Okay? If I do the next one, we'll draw this one more time. Now we're going to revolve around y equals 6. Same thing, we've got a parabola, just a regular parabola, x squared. And then we have this parabola where it crossed at 0 and 4, I believe it was. Yep, 0 and 4, something like that. And we know this point of intersection happened at 2, which my graph's not real good. This should be over a little bit further. This parabola, I should just draw it again. Let's make that better so that you guys don't get confused. Here we go. My x squared parabola, make it a little bit skinnier so that way it's not misleading. Then 1, 2, 3, 4. So we're going to go. second time I'm gonna have to do that, I'm sorry. Just fast forward this part if you want. So x squared looks like this, and then 1, 2, 3, 4. We're gonna cross at 4. There we go. So we're gonna cross 4, and that should cross at about 2, roughly. Okay. And this is the area of the region we're looking at. And now we're gonna rotate it around y equals 6. Now, y equals 6 is pretty high. It'd be a good idea to know what this point is. It's 2 something. I put 2 in it, it's actually 2, 4. So y equals 6 is actually going to be, that would be roughly 4, 5, 6. So this has got all kinds of gap in it. It's not just a gap because you got this funny shaped thing here that you're rotating around that. But I have no clue what this will look like visually, three-dimensionally. But you're rotating this blue area around this horizontal axis of rotation up here. So we're rotating around this. So outer radius, it's pretty fast when you get the hang of it. Outer radius is going to be this, inner radius is going to be this. So outer radius is going to be top minus bottom. So I'm going to go 6, this is 6, minus the bottom function, which is x squared. Inner radius is going to be top function again, 6, minus the bottom function, which is 4x minus x squared. So you got to be careful there because you're going to have to distribute a negative. So I'm going to go ahead and simplify. The inner radius would be 6 minus 4x plus x squared. So there's inner radius, outer radius. So it'd be volume, pi, don't forget your pi, from 0 to 2, we're along the x-axis still. And then we're going to go from outer radius, which is 6 minus x squared squared, minus inner radius, which is 6 minus 4x plus x squared squared dx. And there's your setup. And then you type it in your calculator. And when you do type this in on your calculator, you should just do this right here, do the integral, and then just put pi in the answer. So whatever this equals, if it ends up being 256.4, then just put your answer as 256.4 pi. Leave your answer in terms of pi. And again, hopefully that will help you as you guys take a look at your homework this weekend.